Hi. Very quick intro. Welcome to Seeqnce. For those who don't know, it's an internet startup accelerator. We have resident internet startups in the red space, including Joe Gabo, who's founder. One of the co-founders is Youssef. We basically help startups go from idea to building a team, to get investment, to get to a place where they can actually release a product, move on to the next stage of their lives as startups. Here, this is a community environment of Seeqnce, where we have a lot of community events, such as workshops or presentations or any other type of things related to internet startups. We only do internet web and mobile startups, by the way. We have a lot of really cool things that we do at Seeqnce. I just encourage you to check out our website, obviously, seeqnce.com. That's it. Today we have a very cool workshop, and we should start with it quickly and immediately. So this is Youssef Chaker, the CTO and co-founder of jogabo.com.
Thank you, Freddie. So today we'll be talking about best practices. It's a two-day workshop, or presentation. The first day we will go everything into the why, what, and how. Day two will be more deep into some of other processes and beyond the preliminary stuff. But first, why are you listening to me? Why not somebody else? Why do I have the experience to tell you these things? Well, I graduated from UVA, University of Virginia, with a degree in computer engineering. After that, I spent about 3 years with Open Source Connections. Open Source Connections is a small consultancy in the US, and we mainly dealt with local businesses, universities, and Silicon Valley startups. Some of these are examples like Baby Center and Take a Fly are San Francisco startups. Newswise is a local business. VCU is a university. And throughout my career over there, I led projects from mostly web development, but a little bit of mobile development as well. And for us, it was the entire package. It wasn't just building software, but it was also about the process, the project management, training the in-house teams that they had so that they could take over the applications. So I did a lot of transfer of knowledge for them. Also, during my time at OSC, I was part of the Agile Civil group, which basically met regularly, just talking about all the new things in Agile and how to learning from other people's experiences. For example, we had people from Rosetta Stone, if you've heard of them, the language software. They would come and share their experiences. Old Dominion, the big company, plenty of other people that would come in, and we would share experiences about how best to manage teams and share best practices. I also did a side project, which Ruby CMS should I use? That's kind of a fun little thing. Since the CMS world is, everybody has CMS at some point. And then after OSC, I joined my two co-founders to work on Jogabo, where basically was the lead developer doing everything for the website. So obviously throughout this time, I gained a lot of experience in the field. So I'm happy to share that knowledge with you here today. Let's talk first about the why. I'll start with the positive. I'm hoping that you guys think of yourselves, or at least people think, I don't know, if you aspire to be more than just code monkeys, which a lot of people think that that's all developers are. There's a famous ad, it was a Super Bowl ad at one point in the US about the monkeys in the office playing around and all this stuff. We don't want to be just that. Developers are more than just people who just execute code. We definitely want to have a better relationship with our customers and biz dev people. A lot of the times we get this bad rap for not necessarily being nice to deal with. else understands, or at least they claim that they don't understand. So it's hard to communicate back and forth with them. So we want to avoid that, and we want to have a better relationship with the people who don't understand what we're doing, to make sure that everybody's happy, that we continue working on what we're doing, and so that's very important. At least for me, that's very important to keep. Plus, we are professionals, supposedly. So I want to show you how to best, embrace that. And I've seen people, take it very personally, take some stuff very personally, and not be able to overcome that and overlook that. And that usually creates a bad tension between people. So I'm hoping to teach you some of the stuff that will, help you accomplish these things. But if you're not convinced yet, there are warnings. There are plenty of examples that we've seen in the software development field. Everybody here is familiar, we're all of age to be familiar with the Y2K problem, or supposed to be the Y2K problem. There are other examples of it. Examples of people who are supposed to be doing their job but end up not really doing it. The Ariane 5 flight, 501, is an example. It's basically a $370 million mistake. So it was basically, the whole problem was inadequate protection from integer overflow, which is, in theory, is a very simple problem, something that could be very avoidable, but without the proper processes in place, these things are very easy to find yourself caught up in a problem like this. So there are other examples, like the Therac-25, which is a radiation therapy machine, and instead of helping people, it ended up killing people because of a simple integer problem, and people were giving massive overdoses of radiation. Some people got approximately 100 times the intended dose. That's a big mistake that causes people's lives, and it's another example of a situation gone bad, which could have been completely avoidable. In sports, I'm a big sports fan. Judo is a soccer social network. So I'll use sort of the example of the sport analogy. Usually when a team makes a mistake, when a team doesn't underperforms, it's the coach's problem. And usually they're the ones who get fired, get kicked out, and not the players, whereas the players are the ones who actually need to be the one performing. In the development world, it's a little bit different. The developers get the blame for almost everything, even if it's not their fault, even if it's the people's fault. So, what do we do about this? Well, hopefully I'll have the answer for that for you. There are more, obviously, examples. There are cases of American or British companies collaborating with German companies, and one company using inches and the other one using the metric system, and they did the conversion, and you get a missile that explodes in the middle of nowhere, or it's just stupid things like that. Plenty of examples. If you go to that Wikipedia page. So hopefully, the fact that you're here means that you guys are on board and you want to avoid these things. I will not go too deep into the whole design patterns. I'm sure if you've taken test courses in college, you've taken a design pattern class, which the book of five, I think it's called, famous one. We've all seen that book. We all know about all the design patterns and also the anti-patterns and the code smells. So I'll not go into that because you've already seen these. But I've seen people who have been working in the field for about 10 years or more. Supposedly experts, experienced people that have been developing software, any kind of software, for a long time, and they make some mistakes, and I will highlight two of them for you right now. That for me, I cannot understand how people still make those two things. Those to me are known in the software field. So hopefully you agree. The first one for me is shortcuts. Quick and dirty. People believe that if they do something fast, it's okay. They'll recover from it. They'll come back and they think, I'll come back and fix this later. But really, what you end up with is a bunch of comments saying, to do, fix me. And you start with one, you end up with about 100. I've written code like this, but very, 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 very little. But everybody makes that mistakes and think that I'll come back later and get on to code. It usually doesn't happen because usually you don't have the time to do it. Usually there are more features to be written, there are more things to do, and you never come back. No matter how good you think you are, this is what's going to happen. But also, quick and dirty means what some people do is solve the problems that they think of the best path or the most common path, and they write code to handle that situation. When usually it's you got something else that something that you haven't thought of, a path that a user might take using your product that you didn't think of. That happens all the time. Writing variables or using magic numbers in the code instead of writing variables, and then when you have to change, when that variable changes, you have to change it everywhere, and you might miss it in one place instead of using a variable once and changing it once. So people get caught up in this a lot, and I've seen it hundreds and hundreds of times. Another one for me is live coding. Might not see live coding. So live coding. I've seen startups at least, but even experienced developers do code, in this example, on servers. Immediately go to the server and change the code on a server while their users are using their website, and everybody thinks, oh, I write good code, my code is perfect, nothing's going to happen. Well, usually something will happen, something wrong will happen. No one writes flawless code. But to solve these problems is very easy. It's so simple that that's why, for me, it's something that nobody should do, because the alternative is a lot simpler than actually doing these things. Now, this was an example that happened with my ex-boss at OSC. His name is Eric, and somebody else was working with us and wrote him this little prayer. It says, Lord, please protect our biggest VPS from Eric's installed software, including but not limited to plugins and gems written by 11-year-old Pakistanis. May his apps be well behaved, and may they be considered of CPU and RAM. Lord, if any of these terms are unfamiliar to you, look them up on Wikipedia. Please speak all other apps and all other VPSs on the same physical server. Amen. What Eric did, he does that all the time, and once what he did is he wrote this little script that ended up sending about 1,000 emails to an app or an API per second. And they were just sending tickets to a ticketing service, not flying tickets, but bug ticketing service. They were sending about 100 or 1,000 emails a second, and their servers were just filled with email requests, ticket requests from him. So this is how this little prayer came to be, and that was my mentor. So yeah, this is who I was trained under. So don't be the guy that gets this little prayer put up on the wall in your office. So what to do? Well, there are some things that you already know. Follow coding standards, be consistent, simple code. Simple is better than more code is not better code. Exception handling, make sure you catch specific exceptions versus the general exception, because somebody else, you might be using plugins that somebody else has written and you don't want to confuse these things. When you're writing code, a lot of people, or at least I always thought at first using variable names like I, J, and K. Well, these things are usually not expressive. They don't tell you what the intention of your code is, so you have to write tons and tons of comments to explain your code. Well, you can avoid that by writing, using variable names and function names that actually tell you what your intention of your code is, or tell the people who are reading your code what the intention of your code is. Even yourself, because you will come back to the code 6 months later and not remember anything that was going on, and we'll have to spend an hour trying to figure out what that code was supposed to do. Another one is common is understandable comments, because if you write comments that, what happens with people is they write comments that explain one thing and the code actually does something else and people get confused, or they write a comment that explains the code and then they change the code and never update the comments. So if your code is understandable, self-explanatory, you don't need the comments. You're better off with other comments instead of writing bad comments. Another set of things, positive dependency injections, don't use too many arguments, think twice before defining a method in a static, avoid using messages with reference parameters, all this stuff. So you probably know all these things, but what school did not teach you, or what your professors probably failed to mention, deliver often, because when you're writing a software, any kind of software, but more specifically, let's say web application, when your users get to use your application, you get better feedback quicker. So deliver often, deliver continuously. Don't try to outsmart your customer too much, because at the end they're the ones who are going to use your product, not you. So you might think you know better what they need, but don't give yourself too much credit in that terms. There'll always be surprises of how your users will use your software. And do what is necessary to deliver the functionality, and don't give too much, because overloaded software becomes unusable. Simplicity is key. And the last one, make sure you love and care about your work, code, user, and customer. Because if you don't, you basically deliver shitty products. And we don't want that. So far, before we go into a little bit more deeper stuff, any questions, comments, concerns? All right. Well, motivational products don't work, but our demotivators products don't work better. According to demotivators or despair.com, motivation is a feel-like cycle. You start with new motivational stimulation, it produces irrational enthusiasm, it gives you inevitable confrontation with reality, and then you go back to that cycle. What they do is they provide the motivators instead. But not all cycles are futile, some are life-saving. So this is why we're going to be talking about test-driven development, or TDD. TDD is basically a methodology for writing software that focuses on writing tests for your code. But not just writing tests. Writing tests first. You write your test and you let them fail. And then you write the minimal code that will make your test pass. So you write your test, you write your code, make your test pass. And then you write more tests. And then you repeat, rinse, lather, repeat, and continue that cycle. Now what you have here is not just only tested software, but you also are writing software, the code that you're writing, you know that you're writing the things that you're supposed to write. You don't find yourself writing a bunch of code that doesn't serve any purpose. You might find yourself going into starting to write a method, not knowing exactly what you're going to write, what what the structure of the code is going to be, and you find yourself writing a bunch of if-else statements that handle every single scenario that you might think of. And 3 hours later, you look at your code and it doesn't do what you actually intended it to do from the first place, because you don't have anything that checks the sanity of your code. When you write your test first, you know exactly what the problem you're trying to solve, and then you write exactly the most minimal functionality that is supposed to make your test pass. That way, you're sure you're writing the software that you need to do, and you're not wasting time doing something else. This is more of the cycle put in perspective. So usually, when you're trying to write something, you start with writing the test. You run the test, and it fails usually because you haven't done anything to make it pass. You write code to make the test pass, and you repeat. And as long as you have things to write, as long as you have tests to write, that means there is more functionality, then you keep doing this cycle. This is actually known as TFD, or test first development. TDD requires one more thing on top of that. TDD is actually TFD plus X. Does anyone know what X is? You guys?
Progression around do the TFD at each.
No, that's still TFD. Yeah. Well, refactor. Simple step, but that was missing out of it, which gives us this actual diagram. You want to keep on refactoring until you cannot take anything out anymore. And basically, because what we're doing with refactoring is we're simplifying the code, we're making sure the code is clean, understandable. But with the test that we have some confidence with our refactoring that what we're doing does not break our code and does not give unintended consequences. That's why you have that circle right here, where your tests pass and you keep on refactoring. If they fail, you have to figure out what made it fail and fix it. But you can continue moving forward with confidence that your application is still doing what it's supposed to do. But overconfidence, before you attempt to beat the odds, be sure you can survive the odds beating you. That's one of the motivators. Passing tests gives you the confidence that what you're doing works, or still works according to what you had planned. But you might not think of every single path. Most developers probably think of the happy path and a few extreme cases, but there usually are a lot more cases for your application that you probably forget about. So if your tests pass, doesn't mean that everything is okay. You will still have some surprises. So just tread carefully and don't be too confident. This is the cycle again. I want to emphasize it. It's the same thing, just different way. It's a good process to memorize. I follow this all the time. To a lot of people, writing tests takes time, so they think it's a waste of time, but it's not. It actually saves a lot of time because you make sure that you have the right process going in. You know what you're doing instead of just trying to write lines of code and end up doing nothing really important. TDD is actually less fluff, more stuff. It keeps you focused on the functionality that you're going to write and what you want to accomplish. But also with your test, when you write your code like this, what you're doing is you're testing your intention. When you start at first with the test that you write a test that basically describes the intention of what you're trying to do. What that also means is you don't have to write comments as much because you have the test that express that intention. And if somebody else wants to take over your code base, or you bring somebody new that has to learn the whole application, they can just read through your test suite and sure that you write tests that express the intention of the code. And do not write tests just so that the tests fail, or do not change your tests just so that the tests pass. If the test that you wrote is correct and the intention is still true, because obviously later on the business plan might change or what your application has to do changes, so then you might have to change your test. But if the intention is still correct for the test, don't change the test code to make it pass, because that means you're not testing your intention anymore. You're just making the test pass. Change the code that's supposed to make the test pass. Change that until and I've seen people do that mistake. Just this is supposed to be true, but it's false. I just change it to false instead. Hey, the test passed. You're breaking the cycle here. You're not really accomplishing what you're supposed to be accomplishing. It's very easy to write tests because every single language you can think of has a testing framework. These are some examples. Jasmine is for JavaScript, along with JUnit. PHP is for PHP. N is for .NET. XUnit is for XML. RSpec for Ruby, and Python and PyUnit for Python. There's plenty of other ones. So you have no shortage of framework and help, so you have no excuses not to write tests. This is an example. RSpec, here I'm using Ruby and using RSpec to write my test in a Ruby on Rails app. And here you can see how I'm describing my intention. On top, if you can see, it says it should require login. Basically, we're testing the user, and the user should require login. If I create a user without a login, it should throw me an error. Minimum of 2 characters. I get something with less than 2 characters, I should have an error as well. More stuff about login and email should require an email proper format. I write these first. Now, depending on the code of what you're trying to test, for these they're simple enough and they test the same thing. I write the 3 of them, or the 3 about the login, for example, 4 about the login, and then write my code. But if the method is small, you should write each test first, then make it pass, and then come back, stuff like that. But obviously this is flexible, depending on the complexity of your code you're writing. And then after that, I just have my Rails code over here. There's a little bit more than the test shows, but validate all the stuff. One example here is the email, and I validate that the email is present, which will make these tests pass. The other ones, they're handled by a plugin, so that's why I don't see the actual code here. And I will not run this live because it'll take some time, but this is an example, 2 examples. Outputs, basically, I run RaceSpec that will run all the tests for me for the entire app. Green means it passes. The yellow star over here means I haven't written the test yet, it's pending. And if you see red, that means it's failing. Then you have to fix your code to make it pass. It's 2 runs, one with and one without the pending tests. So it's as simple as that. So I'll actually give you a break over here for 15 minutes before we continue. So we will delve a little bit more deeply into some of these things. Sorry for the delay, there's some technical issues. So we were talking before about TDD, but I have a question for you. Why are we writing code? What's the purpose of the code that we're writing? I know you know the sense.
Solving problems. Solving problems and making it easier for clients.
Making it easier for clients.
Why are we writing code? So we can get paid.
Okay, but why are the people who pay you asking you for your code?
To get a product that they can use.
What's the product supposed to be doing?
Make money.
Money-focused people.
For a certain customer or for a group of customers, it's for commerce or for personal use.
Okay, so along those lines, it's made basically to solve business problems, making money, but also other type of problems, and do certain behavior. Usually, your software is supposed to help people do things, to behave. So we're talking about test-driven development, but maybe we should be talking about behavior-driven development. So behavior-driven development is actually a superset of test-driven development, TDD, and you have this part, which is the TDD part. What we add to it is this part right here, which is the acceptance kind of driven development, acceptance tests, acceptance criteria, is where the people that ask you to write the code, usually a biz dev person or a customer or client, they have a certain behavior in mind that they want to accomplish, to see out of the software. So your business owner, who's tasking you with this, with the coding, has some acceptance criteria. The software is supposed to do X, Y, Z. Your user needs to be able to watch videos if you're YouTube. Your user needs to be able to have friends and see their pictures if you're Facebook, right? So those acceptance criteria that your product owner or business owner, they write those acceptance criteria, which can be also transformed into acceptance tests. It's the same cycle. You run your acceptance tests. You see if your software does the intended behavior, and you continue the loop. You make changes to your code. You write the unit test that test the actual functionality. You put that all together, and you got BD. The purpose of it is to make sure that what you wrote actually solves the need for your customer, and not what you think the customer needs, but what they actually need. Because sometimes there might be confusion. Now, the example that I actually showed earlier with the RSpec code is actually more of a behavior-driven development of test, because it tested the intention of the code. But we'll go a bit more deeper into what BD is. So part of it is user stories. User stories are supposed to capture a few things, mainly the who, what, and why. And don't mind the bad handwriting. And so an example of a user story would be as a, whatever your role is, I want to behavior, whatever the behavior is, so that whatever your intention is. And we can fill those in, so this is a kind of a template, and you can fill those in with, as a user, as a Facebook user, I want to search by first and last name, so that I can find a friend and add them on Facebook, right? So this is kind of the template. So when you write user stories like this, you basically are defining the behavior that you're expecting from your software. And with the completion of the user stories, if we write the example as a user, I'll just write, I want to search, and here is implied by first name and last name, so that I can befriend. Alright, this is a shortened version of the example that I just gave. When you're looking at this user story, you can deduct from it are a few things, and those are your features. As a user, which means that you need to have a user. A user needs to be able to register, log in, all this stuff. I want to search, so you need a search functionality, and befriend means I need to add as a friend to my network. So you can deduce from this example all the features that you need to build for your software. On top of that, what you will be, you need to have is scenarios. So basically, how is this happening? What is the interaction between all the different features that you're writing? Your user, first of all, for example, let's say the user is already registered, the user has to log in to Facebook. And then once they log in, they have to go and type the first name and last name in the search box. They click enter, let's say, or hit on the search icon. Then they see the friends. Once they see the friend that they're looking for, they want to click add on the button add as friend. And they see a notification, a message saying you just added X, or you just sent a friend request to XYZ person. So that scenario basically ties in everything that the user is doing or how they're interacting with your product. An example would be this. This is Gherkin, kind of a human readable language that will be then translated into code. It's used by Cucumber, which is not the fruit, not the vegetable, but the software that helps you write user stories. The funny story is the person who wrote Cucumber had written this software and didn't know what to call it. So he looked at his girlfriend and was like, what should I call this? And she was eating a cucumber, so she said cucumber. That's how it was named. But basically, if we can all read this, everybody can read this, and the point behind it is that even your product owner, or not even, in fact, they should be the ones writing these scenarios with you. And in this case, is someone on Google who wants to be able to browse the other user's profile. So and the purpose is, or the intention that we have at the end is in order to find new players for the pickup games, the site user wants to be able to view all of their profiles. And the different scenarios are a user that's logged in, they view the, and Joe Smith is a random user that has existed. I'm looking at Joe Smith's profile, then I should see Joe Smith's basic info. And in this scenario, in this case, it's first name, last name, age, and position that they play, forward or defense or whatever. And we have another scenario which is the non-logged in user, and we actually allow people to see other people's profiles even if they're not logged in. So we have another scenario that explains that behavior. So this is also known as integration testing, or what I just showed you here with Cucumber. Why? Because when I wrote the scenario first of all explains the behavior, the intended behavior of the product. But with Cucumber, it's not just about writing the scenarios that are basically some form of documentation for your software, and a way to test the intention and make sure that everybody's on the same page, the developer and the business owner. But also it runs a test and makes sure that those scenarios actually are correct, and that the software actually complies to those scenarios. So that piece of code is actually testing the entire integration of the whole site as if somebody's actually using it. And I will show you them. Now this, actually, I will open my terminal, where is it? You. Right. You tab, ignore the first couple of things because I have to close the terminals and I have to start again. So I'm going to run the same feature that we saw, which is the browse profile feature. And it will give it a second to think. And while this is thinking, I know a bunch of you, what you do is you do manual testing. Basically, you go through the site yourself and try to click on everything and make sure that it works. Well, that works, except that it requires a lot of your time, and it requires that you actually have written some sort of script somewhere that makes sure that that you actually don't forget anything, and that usually is it's hard not to forget all the scenarios that you're supposed to run in order to application. What this instead helps you do is it does that all for you. And we'll see that in a second. It's actually pretty cool because it acts as if the user is actually using your website and tests all the scenarios that you've written and told it to execute. Starting off is slow depending. Have a old MacBook Air. It usually is faster.
Do we tell it the input and the output, what should be the output?
Yes, and I will show you how. But you see here, it's running. Come on. Yo. Sorry. So you see, it's actually going through the whole website, or the features. So signing in as a player, going to the settings, or creating this. So you can see it run actually as if somebody, a real user is actually going through it. So in this case, we're looking at somebody's profile. It runs fast enough so you might not be catching on everything that it's doing. But you can tell that, for example, here, if I went too fast, it showed you how you're browsing, and a non-logged in user can browse another profile, another person's profile. You see here, this is the non-logged in way. We have the banner at the top. So this is an example. You can tell it, so you can test everything, and I'll show you actually. You can see it now because it's using that. So you can see green is that it's passing. It's going through, thrown through step by step, and it makes sure that every step is passing. If it doesn't, it will give you red. It will throw an error saying something failed. So this is, well, it runs. I'll answer your question. Find my mouse. Basically, browse profile feature. So this is the feature that we saw, and browse profile steps. So, there's not too much here. And these lines basically correspond to steps, and one of them is this one right here. Hold on, let me give it the correct steps. So I should see we're taking variable here, which is the login of the user, it's basic info. And basically, I define this as saying the page should have the content, and what the content is the player's full name, the login, the location, and the description. Right? And what this does, the Cucumber, in this case, is using another tool, another plugin, to actually look at the pages and match the content. And so you tell it what the expectations are, and it tests and make sure that the expectations match reality. So this is one example of them. You can tell that I have plenty of them. So here are different features. This is all the features that I have, and each one has its supporting steps. Some of them are, let's say, as repeated an event. You can see I have different scenarios of what are all the possibilities of a person trying to RSVP to a game. So basically, this is an example, and you can tell that it actually goes through the entire scenario from A to Z, from the moment that the user logs in to the moment that the ending is when, let's say, RSVP yes to an event. And you test that the entire process actually works. So you're sure that when a user is actually doing the same thing, that it actually works for them. And you don't rely on your own self, because we make mistakes, so we might not be able to test every single scenario. And when you look here, I mean, if an actual person has to go through every single one of them, I mean, here this is 157 lines of scenarios. This is 122. It's a lot of. There's 65. So you see, some of them are small, but there's a lot of them that are very big. And if an actual person has to go through every single one of them, every time you write a feature, it will take forever and you'll never get through it. So that's why you do integration testing, but also that is also why you do continuous integration. And basically, continuous integration is your integration testing that's run continuously. What we just did with the Cucumber test is an integration test. What you do, continuous integration is the fact that you run those all the time, every single time that you make any change. And that makes sure that your code base is still, doing what it's supposed to do. And nothing that you've changed, whether by mistake or intentionally, alters the behavior of the website. For integration testing, you've got plenty of tools. The best known is cruise control, and it comes in different flavors: cruise control.net, cruise control.rp for the different languages. You got Jenkins, you got Hudson. Hudson is very popular, cruise control is very popular. And those are tools to make all your integration testing automated. So every time you make a change, you configure your script, you configure your automated tools to actually run your entire test suite by itself. And that way, you're always sure that any change that has been made is tested, and nothing in the site is broken or behaves differently than we expect. Now, you don't have to necessarily configure. These are heavy tools. You will have to go through a lot of configuration and a lot of stuff for it. What you can do is monkey CI. Now, I don't know if anybody else uses that term. Probably coined that term with my previous company. And basically, monkey CI is every single one of us running the integration test suite by himself and putting in the status on the board, on the whiteboard. YC stands for me. EEP stands for Eric, the famous Eric from the prayer. DB stands for Diana. So you can have a continuous integration system that's manual, but basically does the job, and you keep on checking that. You see here the time that we have run everything. So you don't have to worry about your application. It's another movie. Because we're only 7 people at least. It's sort of what integration tool, continuous integration tools feel like. So actually, this is if you want to stand up, stretch real quick, this is your opportunity. Real quick, stretch. All right. Alright, so if there's anything that I want you to take away from this is what I'm going to talk about next. For me, this is the most important part, just because testing all the stuff is great, but without this, for me, I believe I cannot do any software development without the next part. And the next part is version control. Now we've got different examples, different types of version control or code control, source control, which is the client-server model, like CVS and SVN. I will not spend too much time on these because these are basically all the analogies. If you're still using CVS, I'll kick you in the balls. If you're using SVN, I'll let it slide, but you should be using something else.
GitHub. Okay.
I'm glad. Okay, somebody. I like this group of people. They know what they're doing. So distributed models are FossilGate, Mercurial. There are obviously others. The difference is you got the distributed system does the peer-to-peer approach, where every single developer has their own local repository and working environment, as opposed to the other one where everybody has to connect to a server. And distributed model is faster because all the most popular commands with like checking, pulling, pushing, all the stuff, all the other ones, the branching and merging happens locally, so you don't have to connect to a server. Pulling and pushing are the only ones where you would have to connect to a server and try to, and require some time through your internet, depending on your internet connection. So, obviously every single tool that is out there, whether it be a programming language or source control or continuous integration tool, if it has all the applications that surround it, that will make it more popular. In this case, Git has jumped the gun because, or risen up above everybody else because of GitHub. GitHub, I heard some people say GitHub, so GitHub is basically a social network for Git. But they did what nobody else has done using source control, and they just made it very easy to use Git. So for me, it's the choice whenever I'm developing. Now, what does source control help you do is you can delete code and feel confident. Now remember the overconfidence, the motivator I showed you. With source control, you can be more and more confident about what you're doing because if you lose anything, you can always get it back. If you can just delete a bunch of code and start all over again, because if you need it back, you can go back and fetch it from source control. And I want to, specify, use source control even if you're the only developer. I've had the same excuse from many people. Like, I'm the only one, I don't need source control, I handle everything. Well, you might make mistakes, delete a bunch of code, not realize it, and then continue, and you're stuck. You can't retrieve that code. Or when you remember the one when I said don't do live coding, code immediately on the server. Well, with source control, it's very easy. You do your development locally, and you push the source control, and you can have an automated script that pulls back on your server and deploys everything. But at least at that point, you can also have your code pushed to your automated test suite or your continuous integration server that runs all the tests and notifies you if something fails. So even if you're the only person developing, it saves you a lot of time and a lot of trouble and headache. Some people I've seen do is change code locally, copy paste to the server. Well, you might always miss something. With source control, you don't have to worry about that. I've seen also people, like, for some people, when you push something and you can't retrieve your code back, your users start, or you figure out, oh, I did something by mistake, your users will start complaining because it will take you a long time to try to figure out what you did, versus with source control, you can just easily retrieve that code, and before your users even figure out what's going on. So, I will show how easy it is to use Git, and hopefully the demo gods will cooperate with this. Oh look, this is the one. Sorry, 1 second. Yeah. 66 minus 5, okay. If you need help with Git, there's a cheat sheet for it. There's a cheat sheet for almost everything. And it's a very good place to start. You can look at all the different commands that Git provides you. I will demonstrate the basic ones right now. First, I'm going to go through the entire process and basically start with GitHub. And then go through the entire motion. So basically, I'm just going to create a repository. Nice thing about GitHub is they give you all the steps that you need to do everything. So at this point, we just created a sample app. Just has nothing right now other than the README file, and we're pushing it to our GitHub. Work. Help me with the magic. Come on, somebody magic. Just. Aren't I lucky? I will let this rest for a second. So what we're going to do here is I want to try to go through kind of the entire process and show you how very simple it is to do everything that we talked about today. I'm hoping the internet will cooperate.
Seems to have a connectivity problem.
Alright, that's fine. I will do is not worry about the installation. But what you can see here is I created a sample app, and there it is. I'll move this back here. Alright. So our sample app right here really has nothing in it. Control, application control, whatever. Now the problem is without the internet I can't install RSpec, so I'll just double click it. Now, assuming you got an application that has done some things, you are a developer that you want to work on a feature, on a specific feature, but you do not want to mess around with the app that is running on your server or whatever, and you want to make sure that whatever changes that you're doing, they might be experimental, they might be a feature that you'll bring later on into the application, but you don't want to get in the way of somebody else. So the first thing that you do is first command. Branch. So you can see, create a branch. You're on master, which is the original one. Create a branch. I'm going into more kind of detail, but there are shortcuts and aliases to all these commands that you can use. So I check out test. So I'm switched to test. So I can do whatever I want. Here, let's set down. All right. So you check your changes, you files, git add, commit. So you're adding all the files you're committing, and you usually put in a message to inform all your developer friends. So what are you doing? I will do this for kind of our purposes. So basically, I committed everything, and that's still local. But what I will not push because of the internet connection, but
It seems to work.
But if I come back here, don't say. Basically, I'm back to the original, which, because I didn't commit the first time because of the internet problem. I just don't have anything except the README file, right? So, as if I have a clean application. Assuming that basically the application had a certain state before you started, you can easily go back and forth. Now what I can do is, let's say I'm happy with all the changes that I made. It's very easy to bring those changes in just by doing this. I can come back here and I see all the files are back here. The change that I made to my applications controller is there, and it's merged to my master branch, which is master, and now I can push origin master. Fetty lied, bastard. All right. Supposedly it pushes back to master, and I have all the changes that I did from my other branch into the working branch. And this is, you can use this, it's so simple. I just did it in front of you. It takes no time to do all these branching and merging and switching back and forth. With Git, it's super easy, super fast, because when you have your working directory or your working repository locally, it's just switching back and forth is very easy. And you don't have to worry about Most of the times, merging is that simple. Very rarely that you have to worry about merging conflicting files or keeping track of what somebody else has done versus what you've done. So this apparently is not running. But you can do this when you're developing on a new feature that you know you want to bring in back to your application, but you want to stay away. You don't want to make any changes that might affect somebody else, so that everybody else can continue working. When you're doing something that's experimental, let's say when I was running my Cucumber feature stuff, you saw deprecation warning. Well, that's because I was switching from Rails 3.0 to Rails 3.2. That's why you saw me use Rails, right? So I want to do that separately from my master branch, because let's say there was a bug that was found and I was still working on the upgrade. The upgrade won't get in the way from me to go back to my master branch, fix the bug, deploy it to my server, and not worry about all the other changes that I was doing. And then I can go back when I'm done, go back to my test branch and continue working there. So it's super easy, super simple, and it saves a lot of time and energy and worry, because from there you have usually a script that logs into your server, pulls the changes from the branch to usually the master branch, but whatever branch that you decide you want to deploy your code from, it automatically update, and you know that your code is going to be in a state that is going to work, and it can all be done in about 5 minutes. And basically, you go from a working repository locally to tested and deployed code super fast. So that's source control.
This is an online repository, right?
Right now?
It's supposed to be online.
Yes.
Okay. Is there something that we can use offline? Because I've looked around and there's nothing really functional that we can use. I don't want to have my code offline. I have online. I want to have something offline.
You can use Git locally. I mean, I did the GitHub process. I went through GitHub, and with GitHub you can still have private stuff if you're worried about privacy or anything. You can have private repositories, but you can set up your Git locally on your laptop and use the branches. Everything that happened except for the push part, all of that was local. So you can have different branches locally. You can switch between them, and all of it is local. You don't have to have a server set up. That's why it's a distributed model. It works with your local repository and your local configuration. So you don't have to rely on a server.
You don't have anything online and private. Do you have that option, or does it have to be open source?
What do you mean?
Like
your code private?
Yes.
Or yeah, so you can set up your own server to host your Git repositories. You don't have to rely on GitHub, for example. GitHub is an example that I'm using, but you can set up your own server, private server, secure and everything. Yeah, exactly. It uses SSH to connect through and everything. And Git, is it Git.org? No, not GitHub. Git okay.com. So they have plenty of documentation over here about how to set up. So if you want any documentation or any news or related stuff for Git, this is where you can go. And they have documentation about how to host your own Git server. And plenty of people do that. You'll find plenty of blog posts, videocasts, and all sorts of stuff that will show you how to do it. It's that simple. If you don't want to worry about that and have to maintain it, GitHub gives you that option. Because if you saw, my Jogable repository, for example, is private, and you see I don't know if it's clear over there. The yellow ones are a private repository that no one else can access except for people that I give access to. The other ones are available. The free plan on GitHub, I think, gives you one private repository, which is enough for most people. I have the $7 a month plan that gives me about 5 or so private repositories. I don't know, maybe more. I can't remember. So that's there. There are obviously other Gitorious, for example, is another service that allows you to do Git. But you get all the options that you want to do this. So you're not limited to anything. Obviously, the technology is open source, so you can make it do whatever you want. But don't fall into the where is it? Right, don't do that. You can build your own excitement piece by piece, right? You can do, if it's open source technology, you can tailor it to whatever your needs are. So it's almost 9. So if any other questions, comments, concerns?
We use .NET. It's not open source, of course. Do you know any version control?
Git is not specific to anything. You can use Git. So the question is, if you use .NET, which is not open source, do you have any version control for right question? So you can use Git with anything that you want, just like you can use SVN or any other version control. So it's not language specific, because for it, all it is files that it's dealing with. So all your files that I use, I don't know if you saw it, but one of the repositories is shell files. So basically I have, they're open source, anybody can go and download them. There are a bunch of configurations for my bash. I'll show you actually some of them tomorrow, so something that I will show you. And so it doesn't care as long as it just deals with files and handles changes basically on patches. So basically the difference between your file right now and your new file, there's a difference between them that it makes a patch out of it, and that patch is your commit. So it actually, that's why it's also a lot better than SVN and it's faster. It's because it deals with every commit as basically the difference between the previous one and the current one. So it doesn't have to upload everything every single time or download everything every single time. It's just the changes that are downloaded as a patch that is then applied to your file. So it doesn't matter what the language that you're doing. You can handle anything that you want. So.
It's like TFS, Team Foundation server. We can make changes, and we can undo the changes if we don't want them.
Yes. I think, TFS is one of the examples. I didn't put all the examples, but TFS I think was one of the examples for version control. That I don't know enough about TFS to tell you about differences, to be honest. But
it's not free. It's not free.
That's one difference. That's one major difference. For example, for me with SVN, there's a big problem that I used to always have is SVN puts a hidden folder in every single directory that you have. And this is how it tracks every single folder that changes. And sometimes you forget that you're using SVN and you delete a folder. And to make it commit, it loses track of everything. And to make that commit go through, sometimes it requires that you bring back all the files again, you delete them the SVN way, and all sorts of stuff. So, or once what happened with me is for example, tagging. If you're releasing continuously, you tag your software version 1, version 2, version 1.2, whatever. And tagging usually with SVN is you have to copy your folder. You have to copy your entire thing and create a tag for it. And sometimes if you do it manually, the copy paste and then it freaks out. With Git, tagging is just like branching. It's the same thing. It's just the same easy. Just you do git tag. You give it whatever the name that you want to tag it as, and the commit message. It's just that simple, so you don't have to deal with all the hassle. Yeah. Any other questions, comments, concerns? Nope. So I'll leave you with this. Because every person deserves an equal chance to prove their incompetence. Basically, for me, every other version of control proves it is competence, except for Git. That's my... So, yes, it's 9 o'clock, so I will see you tomorrow again for the second day. Thank you for coming.